Hello, everybody. Today, we'll talk about equipment and system qualification, and we'll go into the introduction to get started. In this part of the PowerPoint, we'll differentiate between equipment and the systems and define qualification and validation and explain how they are different. So, what is an equipment versus a system? This diagram right here gives you a high-level overview of what an equipment is versus a system. So an equipment, pretty self-explanatory. An example is the tablet mini coating and dry machine. Just this particular machine, which is considered a standalone piece of equipment. When you talk about a system or a process, you're talking about the whole concept of how you turn a raw material into a final product, and it goes through a particular process or through a system. So the diagram on the right gives you an overview of a system versus a piece of equipment on the left. So an equipment is an individual component of a process chain, example, tablet press, toss, or process tank, capable of performing a defined function without other equipment components. A system is a complex process chain consisting of individual equipment that must be used in concert to deliver an output, e.g. HVAC or water generation. So this is an overview of, or an explanation of, an equipment versus a system. Now we'll talk about qualification versus validation. So qualification, this typically is dealing with equipment and utilities. It's a qualified performance and typically one confirmation. And then when you go into validation, it's more typically a processes such as sterilization, purified water generation, and products using qualified equipment and utilities. You want to validate a consistent output, and it's typically several intensive confirmations. So qualification is typically more in equipment, and when you go into validation, it's more of a process system. So qualification. What is qualification? It's documented evidence that process, equipment, and ancillary systems are capable of consistently operating within established limits and tolerances. So this is the definition of qualification. Now I'm going to go into part two, which will discuss IQ, which is installation qualification, OQ, operational qualification, and PQ, process qualification. In this section, we'll explain the V model concept and identify components of the V model of a product from design to market. So when you talk about a V model concept, this is what you're talking about. So it goes into, let's say you have a piece of equipment and you get it from the factory. So if you look at the bottom, it goes into construction factory acceptance test. Then when it gets to the site, you do SAT or site acceptance test. And the right of the V model, you go into your IQ, OQ, PQ, and then maintaining your state of validation on the left side. It's more of, I would say, more right side, more validation, left side, more qualification. It goes into technical requirement specification, functional requirement specification, user requirement, and then evaluation master plan. So the right side is more of the output of evaluation, and the left side is more of the planning of evaluation. So URS, or user requirement specification. When you hear the word URS, this means this is a document defining the essential elements of quality that need to be built in at this stage, and any GMP risks mitigated to an acceptable level. So URS is usually the first document prepared for a system or process, has user needs, intended use, and critical constraints. So essentially the user requirement specification outlines, it's an overview of a piece of equipment that you'll want to have, and it gives you the outputs of the equipment, such as my piece of equipment, it needs to be made of a particular, make of stainless steel or a particular type of stainless steel. It needs to have adequate lighting. It needs to have sample ports. So it just outlines what the piece of equipment, the components of it, and an overview of that piece of equipment. So the URS should be a point of reference throughout the validation lifecycle. So then you have your learner's learning management system or LMS shall provide a capability for managing the training requirements for each job. And if a tank can hold 150 liters of water, can mix viscous products, and can control temperature, these would be your user requirements. So like I said, anything that you want your equipment to do, those are your user requirements, such as it can hold 150 liters of water or it can control temperature. These are user requirement specifications. Next, we're going to the functional requirement specifications. So functional requirement specification is a functional requirement is what you need a system and equipment to do or perform. So it's pretty much telling you how you want your system to perform. So some example of FRS requirements is the system shall require entry of the employee's email address. The system shall send assigned trainings an email training notification, reminder every day until training is complete, or a packaging line that requires high speed to match consumer demand that will need cameras and inspection systems that can match the throughput. So these are functional requirement specifications and examples of that. Next, we're going to technical requirement specification. So design specifications are, they describe how a system performs the requirements outlined in our FRS, key document for the system construction, and specifications may include specific inputs, calculations, and codes, and measures to ensure system security. Next, we're going to FAT/SAT. So test preparation. Test functions are individual testing procedures targeted at verifying the system or equipment functions as intended. They usually consist of following purpose and scope. An example, running a specified autoclave load, frequency, number of test cycles required, test instructions, test equipment, acceptance criteria, and documentation required. Example, laboratory notebooks or deviation resolution. So these are your test preparation. So now we'll talk about factory acceptance testing and site acceptance testing. So prior to on-site installation, your FAT or your factory acceptance test confirms compliance with the URS FRS at the vendor site. So like we said earlier, the URS is usually the first document that's created. Once you have created a URS and has been approved, you usually send that to the vendor and they will build your equipment at the factory. Before it's sent from their factory to the site, the engineers or validation, they usually go to the factory and perform testing to just ensure that the user requirements that we said that we needed, you guys or the factory adhere to that. And before it can be released to our site, we want to test and make sure it meets our standards. So that's what FAT or factory acceptance testing is all about. After you go through your FAT and it passes and is delivered to your site, then you have SAT, which is or site acceptance testing, which is performed following the receipt of equipment at the manufacturing site. SAT could also be performed at the vendor site if it can be shown that the functionality is not affected by transport and final installation. Generally, I've not seen it being performed at the vendor site. Usually, you want to make sure you do it at your site because when you ship a piece of equipment, there's no telling what could happen to it. So you, when it comes to your site, you want to make sure what you did at a factory, the functions of the equipment are still the same when it gets to your site because during transport, anything can happen. You could also provide opportunity to make equipment changes before it's shipped to the site. And the SAT testing can reduce testing in the IQ, OQ, PQ phases. So essentially, this is saying that any testing that you do during SAT, just as long as on a critical or quality attribute, you can leverage that testing and not repeat it during your IQ, OQ, PQ. So let's say in your IQ, your installation, you want to make sure that certain things are installed correctly. If you test that or verify that in your SAT, you can leverage that and say that if it's part of your IQ protocol, that it was done in your SAT. So that's what that's all saying. Now we're going to installation qualification. So installation qualification should be performed on equipment systems and should include verification of the correct installation of components, instrumentation, equipment, pipework, and services against the engineering drawings, and FRS. Verification of the correct installation against predefined criteria. IQ is important because it establishes activities that will be part of the maintenance program procedures. So IQ, you just pretty much verifying that uh, things were installed correctly against your URS or your FRS or your drawings. So this is part of the qualification process. Installation qualification. It's a requirement that supplier delivers sufficient documentation to enable future maintenance, prints drawings manuals, calibration of instrumentation, preventive maintenance and cleaning schedules, and verification of the materials of construction. So these are all part of your IQ.